Okay. Let's review implicit derivatives. But this time we'll do it with respect to time, I guess. So let's start with the basic one. This is probably like a circle type of equation. So we take derivative with respect to time. You do the same power rules, just tack on the chain rule. So derivative of this guy obviously is 2x, right?
Yes.
And then you tack on this chain rule, dx dt. This one is 2y, and then times the derivative with respect to time. Same thing here. So essentially, that's all you're doing. So whenever you do a derivative, when the variables do not match, see this is time and x, time and y, etc., then you have to tack this on. If this was dx, then this would just be 2x, and that's it. Does that make sense?
Yes.
So essentially, in a nutshell, that's all it is. So the homework starts off kind of chill, I guess. Just find dy dt, and it give you given x equal to 6. This is the first example in the homework. Dx dt is given as 10. With the equation x times y equals to 2. Okay, so if you want dy dt, that means we're going to have to take the derivative with respect to time of both sides. So derivative of a constant is 0 every single time. Although I'm going to need more space. Let's do that part last. Because this is going to be a product rule, right?
Yes.
So the derivative of the first term, which is a 1, times dx dt, times the y plus derivative of the y, which is a 1, times dy dt, times your x equal to 0. All right, so just plug in everything and solve for dy dt. Or you can solve for dy dt and then plug stuff in. Doesn't matter. Let's plug in x, which is 6, dx dt, which is 0. So this would be 1 times 0. No, actually it's 10. My bad. I can't read my own handwriting.
No, I also said 0.
Times y plus dx or dy dt times 6. So just isolate this guy. So dy dt times 6 is equal to negative 10y, which I subtract this over, divide by 6, and we are done.
Make sense?
Not too bad, right?
No, hold up.
Although we could solve for y, I just realized, right? We have an equation. We have x. So if I plug in 6 into that equation, y would be equal to 1/3, right?
Yes.
I should have done that sooner. I forgot. Be real with you,
No,
I just totally missed it. So
that one was easy. This one was harder and better to have written down.
what's that?
Well, it's like the Y one was really simple. I feel like this one was a little more complex, showed the steps more, so it was better to have written down.
Gotcha. But so it makes sense, you said?
Yes, makes total sense.
Okay. So when you start, you should probably find x and y and whatever they're talking about, and then find the derivative, if you can. So the first few are just like this, but then they get into the word problems, which are more complex. You'll have one word problem on your 1 or 2 on this next exam. Let's do problem 5. You're cool on this page?
Yes.
Okay. The radius r of a circle is increasing at a rate of 3 centimeters per minute. Find the rate of change of the area when your radius r is equal to 37 centimeters. So these types of questions you're going to need to already know area of a circle, volume of a circle, volume of a sphere, area of a cylinder. So when you do this homework, I mean, you can just Google that stuff, but on your exam, I would bring like basic formulas for areas and volumes, just in case you forgot. I don't expect you to memorize a volume of a sphere or to know it, but you might, I don't know. Okay, so area of a circle, you agree is pi r squared, right?
Yep.
So what did they give us?
They gave us R, they gave us the amount of change per minute of the radius, and then they gave us our set value, which is R at 37 centimeters.
So there's r. So how would you write this 30 centimeter per minute? What is that in this question?
Rate.
That is a rate. So how do we write rates?
Y equals mx plus b.
Well, that's a type of rate. And before, right? So just so we don't forget. All these right here, dx dt, dy dt, dr dt. I didn't mention it, but these are all rates. if x represents like a dimension, this would be the change in x over time, change in y over time, change in maybe radius, I don't know, and over time. So what they gave us was dr dt. So when we read these problems, we have to remember, okay, what is what? What does that mean? What are they saying? So dr dt is the change of radius per minute. Per meaning over a minute, right?
Yep.
Which is the time component dt. That makes sense.
Yes.
So once you have these two, take a derivative of this guy because they asked for what? Find the rate. So this is the key word. So rate of change of the area. So that should tell you, oh, I need to take the derivative with respect to time of this guy. You see what I mean?
Yes.
The derivative of A obviously is just a 1 times dA dt. Derivative of this, well, that's going to be, what is this going to be?
You're gonna do the quotient rule,
It's a
but
pi right there.
and then pi as a derivative is 0. And then 2r would be the derivative of r squared.
Yeah, derivative of this guy is 2r. But do you see that the pi is just a number?
Yeah, that's what I'm saying. The pi would be 0 and the r squared derivative is 2r.
I mean, you could do a product rule if you wanted to, but it's unnecessary. Picture it like
Okay.
this. Like if you had something like this, what would you do for a derivative?
Be 4x.
Yeah, you bring the 2 and multiply it times the other 2, right?
Oh my god. Yeah.
So you agree that this is just 2 pi.
Yep.
Yeah, don't you're overthinking it, right?
Yep.
Anyway, so once you have it, just plug in the stuff that you are given and answer the question. They want to know the rate of change of your area, which is dA dt, when your radius is this, and when your rate of change of the radius is that. So plug it all in and you're good. So 2 pi, just the number. I don't really care what it is. Times r times this thing.
I can't believe I've been doing my homework the complicated way.
Oh, were you doing
man.
product rules and stuff like this?
Yes.
But it did work out, right? It still works.
Yeah, it still works.
That's
It's
funny.
like I could have saved like 3 hours.
Yeah. Well, yeah. If it's just a number, don't worry about it.
Yeah, I'm gonna like make a little note of that and then make sure I read it before the test.
Yeah, you might have. Did you do that with the quotient rule too?
Yes.
Oh man, that's a real pain in the ass.
I was making things so unnecessarily difficult, apparently. Makes me a little depressed.
Well, that's how you learn, right? Now you're gonna remember.
Yeah, now I'm gonna remember because I have all that lost time.
You're like, so
It's not gonna happen again.
exactly. That's what matters. Okay. Centimeters times centimeters is centimeters squared. And it should be squared because we're talking about change of area, right?
Mhm.
Calculator time, that's like 697.4 centimeters squared per minute.
What about the 3 and the 3 centimeters?
Oh yeah, I should put it be right there.
Okay.
Okay. But see the general gist, right?
Yeah.
You find the you write down what the heck they're talking about, then you figure out what formula you need. You take your derivative implicitly, plug in what you have. Sometimes you might need multiple formulas and it gets harder. Depends on the problem, what's going on. But yeah, so any questions on number 2?
Nope. Makes sense.
I'll try that page in a second. Let's do another one.
Okay.
All right. The radius r of a sphere is increasing at a rate of 7 inches per minute. Part A says, find the change of the volume when r is equal to 11 inches. All right. So talking about a sphere. All right. And I'm gonna double check in a moment, but I'm pretty sure volume of a sphere is 4/3 pi r cubed. Let me check.
That sounds right. But who knows?
Yeah, that's right. Okay. You can derive it using calculus 2 or 3, but that's not necessary right now. R is 11. Okay, cool. Which rate did they give me?
The rate of 7 inches a minute.
What's increasing?
The radius.
So how will we write it?
So you'd write it as dr over dt equals 7 inches over a minute.
Yeah. Exactly. Okay, cool. So let's take a derivative and see what happens. Shouldn't be too much harder than the other question, I hope. So the derivative of this guy is a 1 times dv dt. Derivative of this would be, what would the derivative here be?
3 times hold on, so 4 pi?
Yeah. Yeah. 4
I was like,
pi
wait, there's another 3 here.
times
R.
pi times r squared, right?
Yes.
dr dt. Can't forget our chain rule. Okay. So it looks like we have everything we need. So we should be able to give it the change in volume whenever the radius is 11. So at that specific point in time, when the radius is hit 11, and we have this rate, this constant rate here, what is the overall change in volume? That's what they're asking. So let's plug it all in. So this is gonna be, I don't know what the hell that is.
I think it's 132, right?
11 squared? Or
Yeah.
the entire thing?
I'm pretty sure it's yeah, I'm pretty sure 11 squared is 132. It's that or 123.
That's
I'm
close.
pretty sure it's 132.
It's 121, 121.
Oh my god, what am I thinking of then?
I don't know. I know it's something close by. I don't
I
know.
think it was 132. I don't remember what it was.
I'm curious what shortcut you're thinking of.
Right? Because they made us do all this freaking times tables.
All right. So 4 pi times 121 times 7 will all be in inches cubed. I think the exact answer would be 3388 pi inches cubed per minute, which is some weirdo number in the calculator, 10,643.
Can you move the paper up?
Oh, yeah. Sorry.
Thank you. All good.
Okay. All right. That's pretty much it, that type of stuff. In the review, we'll do some more that are a little harder. But I think the homework, I think that's pretty much what you're gonna see. Let me double check. And I'll adjust those dates because it looks like it closed yesterday.
Yes. I was having trouble. I was like, I don't think we went over this.
Yeah, we haven't talked about it, so I shouldn't be closing yet. My bad.
All good. I
Uh,
was confident you weren't going to keep it closed when we didn't go over it,
yeah,
which I'm not so confident about with other professors. So thank you.
you would think it would be logical, but oh well.
You would hope, right? Sometimes.
I don't know. I guess not everyone thinks like a scientist, I guess. Let's see here. Yeah, I think that's pretty much it. We'll do some harder ones on the exam review.
Okay.
But as far as homework, and let me change those dates right now before I forget. So we're going to use Newton's method to calculate, well, what it's used for is to calculate zeros. Usually you do it in programming, or I'm sure your calculator probably does it automatically to approximate zeros. So we're going to do it manually, which kind of stinks, but we'll just do a couple iterations. We'll just do 2. Usually a program will do like hundreds of them until it's an accuracy of your choice. So right here, this is the function we're working on. X squared minus 5. So you can see that the zero is right here, right? 2.236. So we're trying to estimate that value using Newton's method. All right. So this is Newton's method right here. Although we're going to need the derivative. Newton's method uses the derivative. So here it is. So xn plus 1. So the next value is equal to the last value, or the first one, minus the function at that value over the derivative at that same value. Okay. So our starting point that they're giving us is an estimate. It can be anything really. They're guessing it's around 2. We're going to use this formula to approach the actual 0, which is about 2.23 something. I forget. I forget what we just looked at. So we're looking for x2. That is equal to x1 minus f of x1 over the derivative at x1. So that's equal to 2 minus f of 2 over the derivative at 2. So that is 2 minus, how would that be? 2 squared minus 5 over 2 times 2. So that gives us 2 minus 4 minus 5 over 4. Get a common denominator, add these up. This will be what? 8/4 minus a negative 1 over 4. So 9/4. Right?
Yes.
Okay, so this is my first iteration. So now let's do x3 over here somewhere. So x3 is equal to x2 minus the function at x2 over the derivative at x2. So you can see how this is pretty tedious, right?
Yeah.
This is why computers do it for us, because it's annoying. So the 9/4 minus the function at 9/4 over the derivative at 9/4. So that'll be 9/4 minus 9/4 squared minus 5 over 2 times 9/4. So at this point, I'm just going to use a calculator because it's getting super annoying and I don't really care. Should get about 2.2361. I don't know what they're going to ask you to round to. Just choose that decimal place. And I believe that's what we had, right?
Yes.
Yeah, 2.236. So ours is a little more accurate because we have more digits. So if you do it again and again, it'll just give you more decimal places, but after a while, it doesn't really change. At least it won't change in the first few decimal places. It might change in like the 50th decimal place or 10th. So after a certain point, it's kind of meaningless to keep doing this. So if you were to code this yourself, you would build in a tolerance so it knows when to stop. You say, you know what, stop when you get the difference from my last point and this point or whatever. It has a tolerance within like 10 thousandths of whatever. 10 thousandths place or 10,000th of an inch, depending what we're talking about. But anyway, you're not going to be coding. So on the exam, I'll just have you do it once or twice like this. That's it.
Yeah.
The homework has you do it piece by piece, which I think is fine when you first start. Can you see the homework?
Yes.
Okay. So they ask you, okay, well, what is X? See, N's right here, 1 and N1, N1 and 2. So this is X1, so that's this value, right? Let's plug it in there. Then they ask you what's the function at X1. So plug in 2 into the function. Then they ask you, well, what is the derivative at X1? And you just keep going and then fill in the blank. So you'll end up getting the 9/4 I got earlier, 2.25. Do it again, filling in each little piece. You see how they're I just did this whole thing at once.
Yes.
And they just broke it down. So the first two is just doing that. Actually, the first few, it doesn't change until I guess the number 5. So 1 through 4 is the same thing. I'd say just use your calculator and write down the first part, like maybe like this piece, and then just go straight to the calculator after that. And here it's the same thing, except they're kind of rigging the question into having us find an intersection point instead of a 0. So what they do is say, well, if I set these two equal to each other, and then so that would be an intersection, right? That's when this happens.
Yeah.
So they said, well, let's just set them equal to each other and then subtract it over and call it some other function. So then that'll be this guy, h. So what you're going to do is subtract these two and then just do this process. So your h function would just be doing the same thing that we just did. Whoops, my computer froze. And just equal to 2x plus 2 minus the other function, x plus 9. So just use this function here for the formula up top, up here. That makes sense?
Yes.
So I want you to keep going, and it says do 2 iterations until they don't differ. They only differ for about 2.0 or 0.001. So over here, they don't differ very much. So if I do it again, this wouldn't change really. That makes sense?
It does.
The only thing is, it didn't mention where to start. So I'd probably pick like, since I can see it, I'd probably just put 0.5 or 0.1 or something. So, some random number. Do 2 iterations and I should get pretty close.
And on the test, you'll have it, if you do one like that, where you can get an estimation.
It'll be more like the one we just did. It should be just like this.
Oh, okay, awesome. We don't have to do that.
Do you want to do another one, or does that make sense?
No, that makes sense.
But yeah, here. Yeah, that's pretty much it. Use a formula, plug in a number, do it twice, and you should get good accuracy. If they wanted you to find intersection, just do that little difference and plug in a random number close by and do the formula again.
Okay.
But yeah, that's pretty much it for chapter 3. Let me show you. Okay. Yeah, so we're around here somewhere. So I guess you can review Thursday. Next week, I'll just give you the whole week to take the exam, I guess, and maybe we'll cover one section.
Sounds good.
And if you have questions, we can talk about it. But we'll do the whole review Thursday. Okay.
Awesome.
But yeah, that's it. And then after that, it's spring break, right?
Oh my God, already?
Let me see. Yeah, next week is the last week before spring break. Excuse me.
Oh my God. Okay.
So we'll review Thursday. Tuesday, I'll see if you guys have questions, or if you do. And you just have the whole week to take the final before the spring break starts. I don't want you to be worrying about it on spring break.
Thank you.
So we'll say it closes on, I don't know, the 12th, I guess.
Sounds good.
And I'll probably open chapter 3 during the break if anybody wants to catch up, but I'm sure you'll take care of it before then,
Oh yeah.
so you can have some sort of break.
You know, one would hope, right?
Yeah, I hope so. I mean, I'm hoping that for you.
Yeah.